Okay, tonight we're going to talk about the average atomic mass. Now, all of the masses that you see on the periodic table are average atomic masses. They are weighted averages. Okay, they're weighted masses. Basically, they take into account all of the isotopes of that element in order to calculate. So, it's the mass numbers of every single isotope out there based on the percentage that each one of them is around. Okay, so the atomic mass of an element is actually a weighted average of all of the isotopes of that element. This means you need to know the percent abundance. You know, how much out of 100% of a sample, what percent is this isotope? What percent is the next type of isotope? Okay? And that's what you have to use. You have to use those percentages in the calculation. Kind of like if you were going to figure out your grade in my chemistry class. My grade is a weighted grade. So basically, each category is worth a certain percent. So you need to multiply, well, you got to take into consideration the percentage of each of those. Okay, now let's look at chlorine. Chlorine has two main isotopes. There's chlorine-37, which I will write, the way you're going to see it is this. And then chlorine-35. Okay. Now, each of them are in different percent, they have a different percent abundance. So chlorine-35 is present in about 76% abundance, whereas chlorine-37 is present in only 24% abundance. That means out of 100% of the samples of chlorine, 76% are going to be chlorine-35, whereas only 24% are chlorine-37. Okay, now to find the weighted average, we need to use the decimal equivalent of the percent abundances. That means we divide by 100. So we're going to take that 76% from the chlorine-35, divide that by 100, and we get 0.76. Same with the 24%, we take that, and if we divide that by 100, we get 0.24%, or actually 0.24. Okay, so we're going to use these two numbers in our calculation, not these. Okay? Okay, so if you don't know the exact mass of each isotope, you can use the mass number. You guys know what the mass number is. You can use the mass number to calculate the average atomic mass. And you should get pretty close to the actual mass. So let's try that with the two we have. So we're going to take chlorine. Let me see if I can draw this again. Chlorine-35. There. Okay, so we're going to use the 35 from the mass number, times it by, now remember we're using the decimal equivalent, okay, and then when you do that multiplication you get 26.60 AMUs. Okay, so that's the average weight of this isotope. Okay, the next one is chlorine-37, so we're going to take the 37, times it by the 0.24, and we get 8.80 AMUs, okay? And that is the average mass of that particular isotope. Okay, so now, well, what do we do next? Because we have two different masses. Which one do we use? Actually, now we're going to add up the masses of the isotopes to get the final average of the atomic mass. So we're going to take the 26.60 plus 8.80, and we get 35.48. Oops, that's a 4. AMUs. Now, do not divide by 2. I know the word says average atomic mass, but we've already taken into consideration the averaging part. That was how we multiplied by the decimal. That basically averaged each of the two. So you just add them up. Okay, do not divide by 2 on this one. Okay. Sometimes you know the actual masses of the isotopes. If you do, you can use the masses in place of the mass number in these calculations. So let's go ahead and look at iron. Now, iron has 4 main isotopes, okay? Iron 54, now we know the mass of that particular isotope. It is 53.9396, and then it has a percent abundance of 5.80. Iron 56, there's that atomic mass, and here's the percent abundance. So we have the mass and the abundance of each of the 4 isotopes. So we're not going to use the mass number in the calculation. We're going to use the actual atomic mass of each isotope in our calculation, okay? And this way, we'll probably get a much closer number. Okay, so let's look at the 54. So we're going to take the atomic mass, which is 53.9396. Now, if we were to take the 5.80 and divide it by 100, we get a small number. And a lot of times, students tend to get mixed up on the places, the zero places. Okay? So an easier way of doing it might be just to put in parentheses the percent and then divide it by 100 next to it. And when you put it in your calculator, you can actually put this number times this divided by 100. If you put it in exactly like that in your calculator, you're still going to get the right answer. Okay, which, hang on, write my equal sign better. That's an equal sign, guys, by the way. 3.13 AMU. Okay? So let's do the next one. The next one would be 55.9349 times, and I'm going to put it in parentheses, 91.72 divided by 100. When I do that math, I get 51.30 AMU. Okay, and then we're going to take the 56.9354 times 2.20. Whoops, that's a divide by. Okay. Divide by 100 equals 1.25 AMU. And then the last one is 57.9332 times, and that's going to be a 0.28 divided by 100. It says a little teensy tiny number, and that's going to give you 0.16 AMU. Now, what do I do next? Okay, so at this point in time, we've got to add them up. So let's go ahead and add them up. So we're going to take the 3.13 plus 51.30 plus 1.25 plus 0.16. And when we add them up, we get 55.84 AMUs. Okay. Yay, we finally got the answer. Okay, now, you know, with my notes, you always end up having some practice. So guess what? You do have a practice problem. I only gave you one. Okay, so I want you to find the average atomic mass of neon. Okay, so I will have the answer to this in class tomorrow. So have a good night. Bye.